Okay, this is Unit 4, Lesson 4, Absolute Value Functions. Before we start talking about absolute value functions, let's review quadratic functions. We've spent a lot of time on quadratic functions so far this year. And just a reminder, the parent function is f of x, or y, equals x squared. The domain of a quadratic function, if it is not in context, is going to be negative infinity to positive infinity. The range depends on if it's a maximum or a minimum and if it's pointing up or down. So basically, if it's pointing up, it has a minimum. And the parent function, remember, if the vertex is at 0, 0, then that minimum is at that 0 y value. The axis of symmetry goes through that vertex and is the x value of the vertex. So the range, because this one is opening up, is going to be from 0 to infinity. So remember, the domain is left to right and range is bottom up. The end behavior, as x is going to the right, or as x is getting greater and greater, y is also going up, so it's also getting greater and greater. Both ends of a quadratic point in the same direction, so both end behaviors are going to be the same. My y-intercept, in the case of the parent function, is at 0, and my x-intercept is also at 0. Now, the interval of increase is, when we're talking about the interval of increase, we're reading it from left to right. And so, of course, left to right, x is always increasing. We want to know what is happening. Where is y increasing when we go left to right? And so y is increasing in this way. So y is increasing from the values of x at 0 to infinity. And y is decreasing in the x values of negative infinity to 0. So what is the y? It's basically kind of like in behavior, but not exactly, because we're talking about if we were on a roller coaster, would we be going downhill or uphill? Okay, so when we transformed the quadratics, we had to remember opposite inside, same outside, and what did the A do to our graph? Okay, so, sorry about that, I'm trying to erase a little dot that was left there. Okay, so my general form, A, H, and K, the H and the K, remember, are my vertex. And so the H inside with my X moved it opposite, so this one would be right, and this would move it left. Opposite inside. When I have a negative in front, remember, it just flips it upside down, reflects across x-axis. Now when we have a K sticking out the back end, that's the one that is the same. So this one would be up K and down K. Remember, K is with the Y, and that's the one that moves it up and down. Okay, when my A is greater than 1, it's kind of like a slope in the sense that it stretches it or makes it narrower. And when it's a fraction, it compresses it or makes it wider. We found this similar thing when we did exponential and when we did square root functions. Now today we're going to be talking about absolute value functions, and we're going to use transformations to graph them and to write them from a graph or a table. Okay, so Michelle likes riding her bike to and from her favorite lake on Wednesdays. She created the following graph to represent the distance she is away from the lake while biking. So as she leaves her house, she's headed to the lake. And the lake, we're going to say, is at the vertex 3, 0. And then she goes back home. So she's 6 miles from her house, and she has her whole trip. It's 3 minutes to the lake and 3 minutes home. We want to write a piecewise function for this situation, with each linear function being in point-slope form using the point 3, 0. Now before, we wrote the point-slope form using only the ordered pair at the beginning of the segment. This time we're going to use the same ordered pair for both point-slope forms. And remember, the point-slope form is y equals my slope, x minus x1 plus y1, where x1 and y1 are an ordered pair. And they want us to use 3, 0 as that ordered pair. So we've got to find the slope for each segment. Okay, this first segment going from the house to the lake, I can look at my graph and see that it is right 1, down 2. I could use ordered pairs to find it, but I'm satisfied that my slope here is -2. So for my first piecewise function, it's going to be -2, x minus 3, opposite inside, plus 0. Well, plus 0 doesn't help anything, so I'm just going to leave that blank. And the domain for this segment of her trip is from time 0 to time 3 minutes. Now the second leg of the trip, going from the lake home, I go right 1 and I go up 2. And I'm satisfied that the slope of this leg segment is a +2. Same ordered pair, and then my domain for this part of the subfunction is from 3 to 6. Okay, so this particular piecewise function is called a linear absolute value function. Some of the characteristics of this linear absolute value functions you can see are that they have a point that they share where the slope is the opposite in each direction from that point. It is symmetric about that point, So it's very similar to a quadratic in the sense that it has a line of symmetry and it's going to look the same on both sides of the vertex. So the absolute value function, the parent function, is just the absolute value of x. And remember, absolute value is the distance from 0. And distance is never negative. So -5 is 5 units from 0. So that's why the absolute value of -5 is actually 5. And the absolute value of 5 is also 5. The domain, just like a quadratic, because if it doesn't have context, it's pointing left and right, is going to be -infinity to infinity. This also has a minimum at 0. The vertex is at 0, 0, and the axis of symmetry is x equals 0. That minimum is the y of the vertex. So the range, depending on if it's a minimum or a maximum, is bottoms up. So since this one has a minimum, it's 0 to infinity. And the end behavior, like quadratic, is either going to both be up or both be down. Since this one points up, it's going to both be positive infinity. My y-intercept of the parent function is at 0, and my x-intercept is also at 0. My interval of increase is from 0 to infinity, and my interval of decrease is from -infinity to 0. Okay, so hopefully in class you're going to take some time to plug in some points and discover that the changes to an absolute value function are going to be exactly the same as they are to the changes of a quadratic function. Opposite inside, same outside. So when I have an h, it's going to be right and left, opposite. And when I have a negative in front, it's going to reflect it. And when I have a K, it makes it go up and down. And these are the same. And then when an A is greater than 1, it's going to be stretched, narrow. And when it's a fraction, it's going to be compressed or wide. Okay, so when we're writing functions, just like almost all the other ones we're doing, we need to find our vertex, determine if it's left, right, inside, outside, and find our A using our point to the right of our vertex. So this first one, if I look at this first one, my vertex is at 1, -3. My point to the right is at 2, -4. So my A, going from -3 to -4, is -1. So my equation, y equals -1, absolute value, x, h, and k. So this would be -1, because opposite inside, -3, same outside. It really is that simple. Okay, let's do the next one. We have 2, 3, h, and k. 1 to the right is 3, 4. So going from 3 to 4 is +1. So my A is 1. So when I'm writing my equation, y equals, I don't need to put a 1, x minus 2, opposite inside, plus 3. Okay, next one. I have a vertex at -4, -1. The next point over is going to be at -3. Remember, I'm just adding 1 to the x, and 2. So going from -1 to 2 is adding 3. That is my A. So my equation is going to be y equals 3x minus -4, so that's going to be +4 minus 1. Very, very simple. Now, if I want to write it in piecewise form, I need to determine my vertex. So I'm going to look to see where does it change directions, just like a quadratic. It's changing directions right here. So this is my vertex. And so I'm going to use that as my x1, y1. If I look on the left-hand side of this, my slope is going down 2. And then going from here is going up 2. So it is definitely an absolute value function. So my equation is going to be -2, absolute value, x minus 3 plus 4, and then 2, absolute value, x minus 3 plus 4. So equations should be the same, just different slopes. And then the domain for this part is going to be from, sorry, don't need to put a parentheses there, 1 to 3. And then this one is going to be from 3 to 10. Oops, not 10, 6. Okay, last one, I'm going to graph this one. Okay, I'm going to start with my vertex. And my vertex is -1, 5, h, and k. So -1 and +5. 1, 2, 3, 4, 5. My slope is -1. And remember, I'm looking at the slope on the right from the function because I know this one's going upside down. So I'm going to go right 1 and down 2. Right 1 and down 2. Right 1 and down 2. I'm going to connect those. And then on the other side, I'm going to go left 1 and down 2 because it's going to be a positive slope on this side. So this one would actually have a maximum at 5, and it would have a range would be from -infinity to 5. My domain would still be -infinity to +infinity. My axis of symmetry would be x equals -1. This one has 2 x-intercepts, but we don't know what exactly they are because they are not at nice little points. We could find them by plugging in and solving for x. So, a lot of stuff going on. Your test is still going to be on Tuesday. Don't forget to do the study guide in pair assessment.